this experiment, we're going to take a compound that's made of copper and oxygen and apply intense heat to break it apart. And our ultimate goal is to determine the empirical formula of that compound. So let me show you the equation for the reaction that's going to occur. It's called a decomposition reaction. So we're going to take that compound and heat it up under a strong flame, and we're going to break it apart. So here's what it looks like. So we have some compound that contains copper and oxygen, and for now I'll just put its subscripts as X and Y. And we're going to heat this up, and it's going to break apart into copper metal, and oxygen gas. So at the end, we're going to end up with just copper, and if we weigh the copper, if we determine the mass of the copper, and we can use that to find the mass of the oxygen, we'll have everything we need to determine the empirical formula of the compound. And so that is our goal for this experiment. That we'll be using during the experiment. So this is our Bunsen burner. This is what we'll use to supply the heat for the decomposition reaction. We have some safety goggles. This is a utility clamp, so we can use this to clamp the test tube in place. I'm going to clamp that to this, which is called the ring stand. I have an Erlenmeyer flask, which will aid in determining masses. Speaking of mass, we have an electronic balance. Here is our copper oxide. We're going to put that in a test tube. This is a thick-walled test tube. It'll be able to withstand the very, very high temperatures reached by the reaction. This is a scoop. We use this to dispense chemicals. We have a little weigh boat, so I'm going to transfer the solid onto this when I weigh it out. I have a rubber hose, which I will use for part of the apparatus, along with a 2-hole rubber stopper, and then I have 2 pieces of glass tubing. So I have a bent piece and a straight piece, and then I have some deionized water. So we always use deionized water to clean our equipment, to clean our glassware. Tap water has minerals in it that could cause a chemical reaction that you don't want to occur. Also, when you clean stuff, rinse it with deionized water. It will dry spotless enough, so it'll be more clean than you've probably ever cleaned anything before. So you want to use that as a final rinse. You can rinse with tap water initially, but your last rinse of any glassware, especially the glassware that you cannot dry, you're going to use deionized water to rinse it off. So let me get everything set up and weighed out, and I'll show you what we're doing. So here's the balance. I put the weigh boat on it, but notice the balance is reading 0.52 grams. We don't need to write that down. So what we want to do always when we're measuring things out is there's a 0 button here. So we'll put the weighing boat on the balance, and then we'll hit 0, and then we'll pour the chemical in. So it looks like we have about 1.75 grams. And so notice something. If there's any air waves, or wind, I should say, it will affect the mass. So we want to make sure that we're not, near the balance, breathing on it, pushing air on it. So we want to keep it as steady as possible. So we don't really need that number. You'll see why in a little bit, but that's the amount that we are starting with, 1.75 grams of our copper oxide. I forgot to mention earlier, you want to do at the beginning of each of your experiments is record observations of the chemicals you're using. So here again is our copper oxide. So we want to record things like its color, its state of matter, so whether it's a solid, liquid, or a gas, and then its texture. Is it granular? Is it crystalline? Is it made of chunks? Is it powdery? How would you describe the texture of that solid? So record observations of the solid. You're going to need those later on. Transfer the solid to our test tube. Now, in order to get all of these solid, we want it all at the bottom of the test tube. If there's any that gets stuck to the walls of the test tube, it's not going to decompose. And so what I'm going to do is I'm going to take a piece of paper and roll it up and stick it into the test tube so that all of the solid gets to the bottom of the test tube. All right, before I put the solid into the test tube, I want to set up my test tube apparatus. So I'm going to insert my glass tubing into my rubber stopper. So now you want to hold the glass tubing as close to the end as possible so that you don't break it. And kind of put it in at an angle and push and twist at the same time. It doesn't need to go all the way through. Now I'll take my straight piece of glass tubing and do the same thing. So put it in at an angle, like so. So now we have that set up. So I need to determine the mass of all of this, the test tube, the rubber stopper, and the glass tubing with nothing in it. Put a flask on the balance. This is just to hold the test tube. And so again, I want to zero it. Let's get 0. We want 0 grams with the flask on the balance. I put the test tube with the rubber stopper and glass tubing in the flask. And we need this number. So go ahead and record that. That is the mass of the empty test tube with the rubber stopper and glass tubing. Now I'm going to go ahead and transfer my solid to the test tube, and then I'll weigh that once again. So I'm going to pour this into the test tube. This weigh boat flexes. I'm going to fold it in half a little bit and pour that in here. I get all of that in there. All right. So there's a little bit left on the weigh boat, which is okay. And then I'll pull the paper out. We should have all of the solid in the bottom of the test tube. And there's going to be some of the solid left over on the paper, which is okay because of how I'm going to determine the mass. So once again, I'm going to put this in my flask. Make sure that reads 0 again. Put the rubber stopper on there. And let's get you that value. So this is the mass of the test tube, rubber stopper, glass tubing, and the copper oxide in it. All right, so we have all the measurements we need. Now I'm going to set it up, and we're going to start heating up this solid. Here's our setup. I'm ready to light the Bunsen burner. So I have a gas valve over here. There's a valve on the bottom of the burner as well. And so before I use this is a striker, so just squeeze that. That'll cause a little spark that we need to get the reaction started. Before I do this, I want to make sure I can hear gas coming out of the Bunsen burner. So you can probably hear that. And I can adjust the Bunsen burner flame using the valve that's on the bottom. Okay, so that's one, and then I have this rubber tubing hooked up to here. So remember, the reaction produces oxygen, so we want to get rid of any of the oxygen from inside the test tube. So I'm going to burn that off, and so I'm going to open the second gas jet, and then we'll get the fire going outside as well. I'll show you what I mean. So we want to heat up the test tube slowly at first. If we just apply that intense heat to the test tube, it could cause it to crack. The hottest part of the Bunsen burner flame is the top of that blue cone. I think you can see that okay. So I'm going to lower the test tube so that's in the bottom of the blue cone and is going to heat up as best as possible. So there's our setup. Let me go in for a closer view here. So again, notice the bottom of the test tube. Where all the solid is right at the top of that blue cone. I want to make sure my Bunsen burner stays right underneath where all the solid is. So really, really, really hot temperature. So hot, in fact, that the glass is going to melt a little bit, and some of the copper may even melt into the glass. So we'll let this go for about 10 minutes. Though we can't heat it up too long, we can heat it up too short. So I want to make sure that all of the copper oxide is decomposed. And so I'm going to let this go for at least 10 minutes. I've been going for a little more than 5 minutes, almost 10 minutes. And so it looks like the copper oxide is nearly turned into completely copper again. So inside the test tube we have copper and oxygen. So the purpose of that second fire that's coming out of the straight glass tubing is to burn off any of the oxygen from inside the test tube. So again, if there's oxygen inside the test tube, it will recombine with copper and we will have gone nowhere. We will still have copper oxide inside the test tube. So a couple more minutes and then we'll be ready to turn off the Bunsen burner. It appears all the copper oxide has decomposed. I'm going to turn off just the Bunsen burner and I'm going to leave the other flame going. So notice that the test tube is red hot. That is extremely hot. That is why I clamped the test tube way up. I don't know if you noticed, I put the clamp way at the top of the test tube so that that rubber on the clamp doesn't melt. So again, we're going to let this keep going, keep the other fire going so that no oxygen recombines with the copper that's inside the test tube. I don't know if you can see in there. But we have copper inside there. And I'm going to let this cool down till it's cool enough to handle, and then I can weigh it. I'm going to check the test tube, see if it's cool enough. I'm going to start at the top, touching the top furthest away from where the fire was. And it is still extremely warm. So we'll let that again continue to go until it is cool enough for me to take apart and to weigh. So let's check and see. Definitely cool enough to handle, so I'm going to take it apart and put it on the balance. I have it on the balance. So again, this is the test tube, the copper metal, the rubber stopper, and glass tubing. There's our mass. You're going to want to record that value. Okay, and then one last step. I'm going to take the copper plug, the lab procedure refers to it, out of the test tube. I'm going to show you what that looks like. Sometimes it's a bit tricky to get this out. We'll see if we can get the copper plug out. So I just have a piece of paper here. There we go. So we want to record, again, observations of this. Let's see if I can hold it up close enough for you to see. Put that in the palm of my hand. Let's try that. So again, state of matter is color. It's very hard. In fact, another observation we want to make is I'm going to take this, I'm going to rub it on the lab table. Let me show you too against a white background what that looks like, see if you can see that better. Let me rub this on the lab table. And we should see something pretty cool. A little bit more so it's more dramatic so you can see it in the camera. So after rubbing it on the lab table, we get that. So again, record observations of what you see after it's been rubbed on the lab table. So let's review what happened. We start off with an oxide of copper oxide. We put that copper oxide under intense heat to break apart. This is called a decomposition reaction. Break apart the copper from the oxygen. You can see the chemical equation for that reaction here. So we ended up with just copper in the test tube. So by simple subtraction, we can determine the mass of the copper that we ended up with after the reaction. That copper came from here. We know the mass of copper. We can use that to find the mass of oxygen that was in the copper oxide. And then once we have the masses of both of those elements, we can convert to moles. And we can use that to find the ratio and hence the empirical formula. Now, something that might be a little bit different with our experimental results than the practice problems you worked on, because of experimental errors, any possible random or systematic errors that may have occurred, we're going to head and take that mole ratio and round it to the nearest whole number. So if it's not really close to a whole number ratio, go ahead and round it. Again, we can do this just in this example because of experimental errors. Any empirical formula problems that I give you on a test or on a homework assignment that's not close to a whole number, then we'll multiply by some whole number to make it a whole number ratio. Some other things to think about are possible sources of error. So it's very important to do what is called error analysis. What kind of errors could have occurred during this experiment, and how could they have affected your results? So both be thinking about both systematic and random errors, and again, how they would affect your results. So hopefully you enjoyed watching this. Normally, in normal circumstances, you would be performing this experiment in the classroom here, and so I hope that we can come back to school and you can do some of your own experiments so I don't have to do any more for you. Again, notice too, I didn't go step by step through the procedure. I wanted you to get the essence of it, but please do read thoroughly through the lab procedure that I have posted on Google Classroom and make sure that you understand completely what went on in this experiment. If you don't understand what's going on and what happened and why, go back, rewatch the video on empirical formula, make sure you really have a good understanding of what empirical formula is and then how we determine the empirical formula they compound. All right, thanks for watching. We'll see you soon.